In the y direction, the tension in the y direction was 980 because it's supporting it, positive newtons. So why don't we just find tension in the x direction really quick? How could we do that? We could just take t times the what? Cosine, right, of 52. So if I take 1243.6 times the cosine of 52 degrees, the tension in the chain is 765.7. Good enough. Newtons. So that means that the crossbar should be at least able to support and push out 765.7 newtons. So what do we just do? Let's kind of like take a step back so we don't get lost in all the details. When we hang up a sign for a tavern, it's a classic example of a two-dimensional static equilibrium problem, where the sum of the forces in each direction must equal 0 because there is no acceleration. On a sign, we have to worry about the pull of gravity going down and tension in the y direction from the chain to support it. If you set those equal to each other, then we can solve for the total tension by dividing by the sine of the angle. Then we can go ahead and plug in for the total tension to get the tension in the x direction, which is then equal to the force of the crossbar. So in real life, this would be very useful if you're trying to hang a sign to know how strong of a chain do you need and how strong of a crossbar. But I bet most tavern owners don't do that. They just order their sign, they plug it in, they load up and stock up the bar, and they're ready for business. But if you're building like a bridge, a suspension bridge, or something on an expressway where there's trucks driving over it, you better know how much all those forces are so nobody dies. So in a nutshell, this is a classic example of static equilibrium in two dimensions.